Hi, I'm Ivan, and today I'm going to talk about the guard statement, which is one of the new features in Swift 2.0. In essence, it tests a condition, and if that condition isn't satisfied, it does something and exits out of the enclosing scope. Now, let's break down that definition. Often in your code, you will have functions which need certain conditions to be satisfied in order to run successfully. For example, let's say we have a sign-up form in our app with two fields, name and email. Below the fields is a sign up button. Now, when the user presses the sign up button, the app needs to perform sign up. However, before that, input needs to be validated. They can't sign up if the email isn't valid or if the name is empty. So I'll demonstrate it in this playground. We have two text fields for email and for name. To focus on the guard statement, I omitted all other logic and just implemented a simple sign up function. So we check that there is something in the name field text, and that character count is greater than 0, so it's not empty. And also we make sure that there is an email and that it's valid. I implemented a very simple function here to check if the email is valid. Of course, you would probably need a lot more complex email validation function. But if those two conditions are satisfied, we do the sign up. Otherwise, we need to show the error somehow and exit out of the function. So a guard statement is another way to write this if-else block. It is almost like an if statement which only contains the else block, but not the original if block, and which requires the else block to exit out of current scope. So let's see how that would look like. So we would say, instead of if, we would say guard, and then the condition is basically the same, except that now we need to immediately have the else block, where we would show the error, and then we need to exit out of the function. So first, we change the if to guard, and our condition remains the same. However, now we use the else block of the if statement and used it as the guard block. In other words, guard makes sure that the given condition is satisfied. If it is, the rest of this statement is ignored and execution continues after the guard block, so we'll just get signing up. For example, if we assign values to our fields, we would get signing up printed. So let's do a little test. If we call sign up, we can see that invalid name or email gets called. I'm going to show the debug area. So invalid name or email gets called. That's because both are empty. And if we try to assign a value to them, email field text. Okay, now when we call sign up, it says signing up. So this whole thing is simply skipped. Additionally, and this is the most important thing, guard requires its else block to exit out of the scope. In other words, you have to use one of the control flow functions that will make sure no code after else block will run. If you don't, Swift compiler will complain. So if I remove the return statement, it says guard body may not fall through. So we need to add something to exit out of the scope. So I'll put back the return. Okay. So in our case, we used return. Other valid options are throw for throwing errors, and break and continue for breaking out of a loop or switch statement. Of course, this depends on context. Here, we couldn't use throw without adding the throws keyword here, and breaking out of a loop with break or continue wouldn't make any sense because we're not inside of a loop. And this touches on another important property of the guard statement. You can use it inside of any scope. It doesn't have to be a function, and it doesn't have to be at the top. It is simply a place in your code where you need to assert a certain condition and break out if that's not satisfied. Let's look at an example of a for loop. Let's say we have an array of numbers. So we want to sum up numbers in the array, but only even numbers, and only until we reach the sum of 100. So here's how we could write this. So we set the sum to 0 and go through the numbers. And then we guard against summing up non-even or odd numbers. We also guard to make sure that the sum is less than 100. Then we print the number we're adding. And finally, we add it to the sum. Okay, so now we have two guard statements. The first checks that the number we are testing is even. If it's not, we want to continue. Next guard statement makes sure the sum is less than 100. If not, we break out of the loop. And finally, the rest of our body prints out the number and adds it to the sum. You can also notice here, guard statement conditions are just simple logical expressions. In general, the condition needs to result in a Boolean value, or it can be an optional binding like what we saw in the first example. So what's the purpose of all this? Well, there are two main benefits. We already mentioned one. Swift will make sure your else block in the guard statement exits the enclosing scope. This simply helps prevent mistakes. If you write a guard statement, and in particular if the else block gets a bit more complicated, for example, you may have to do a sequence of operations if the inputs to the function are invalid, then it's easier to forget to exit the enclosing scope. Like in many other things, Swift tries to enforce rules to make sure you don't inadvertently break them. The second benefit is readability. Sure, it's another keyword and generally I prefer to have as few as possible, but compared to an if statement which is used for all kinds of purposes in a program, once you see guard, you know immediately what it means. The piece of code following it relies on some condition being met, and if it's not, the code will not continue beyond this point. So that's all about guard statements for now. Keep learning.